Hey everybody, Mr. Reeves back with you, and today we're looking at dividing rational numbers. All right, just a reminder, a rational number is any number that can be written as a fraction a over b, where a and b are integers and b is not equal to 0. And we have represented rational numbers as fractions, as decimals, and as mixed numbers. And we have been adding and subtracting rational numbers. We recently multiplied rational numbers, and now, exciting times, we're going to be dividing rational numbers. All right, so remember, rational numbers can be positive or negative, fractions, decimals, or mixed numbers. All right, now I spent a long time in a previous video on dividing integers explaining how the signs work when you multiply positives and negatives. All right, so I'm not going to repeat that in this video. If you are curious why these rules apply, go back and watch my video on dividing integers. All right, so a couple things we do want to talk about. Many times we represent division problems as a fraction. So if you take a look here at these, there's a number on the top of the fraction, which we call the numerator, and the number on the bottom of the fraction, which we call the denominator. Now, if we're looking at this instead of as a fraction, but as a division problem, as 12 divided by -4, or this one, -12 divided by 4, then we call the top number the dividend, and the bottom number is the divisor, right? So if I were to write that first one out, it would be 12 divided by -4. That second one would be -12 divided by 4, and then that last one would be a negative, or the opposite of 12 divided by 4. All right, so this first number here, that is the dividend, and this one right here is the divisor. All right, so when you see that OR, that means like the doer, right? If you have the word D-O-E-R, the doer, all right, the E-R, or I know it's O-R here, that means the person or thing that's doing it, right? So this second number is what's doing the dividing. This is what we're dividing, the initial number that's being divided, and the divisor is what we're dividing by. Okay? All right, long story short, if you have two, if you're just dividing here with two things here, a positive divided by a negative will be a negative. A negative divided by a positive will be a negative. So it's just like multiplication. If the signs are different, the answer is negative. And if the signs are the same, it's going to be positive. Positive divided by a positive is a positive, and a negative divided by a negative will be a negative. All right? And they do want to point out something that comes up is when you write it this way, okay, these all mean the same thing. They are actually equivalent, okay, because a positive divided by a negative is going to be a negative, right? A negative divided by a positive is going to be a negative, and a positive divided by a positive, that part will be positive, but once you throw that negative in front, it's now going to be a negative. So are they equivalent? The answer is yes. They are equivalent. All right, now just so you know, in division problems, we can write it any of those ways. When we're writing out fractions, we usually don't put it on the bottom, but we're talking division here. So it could be on the top, it could be on the bottom, or it could be out front. They are all equivalent. All right? Okay, so let's just take a look at some problems. It says write two equivalent quotients, okay? So this is 14 divided by -7. By the way, what would 14 divided by -7 be? Well, positive divided by a negative would be a negative, and 14 divided by 7 would be 2, right? So I could write it as 14 divided by -7. I could write it as -14 divided by a +7, or I can write it as a negative of 14 divided by 7. All of those equal -2. All right, a -32 divided by a -8 could be equivalent to a +32 divided by a +8, right? Because a -32 divided by a -8, a negative divided by a negative is a positive, and 32 divided by 8 is 4, right? So what's a third way we could write it? Well, we could write it like, wow, gosh, what would they want us to write here? I'm not quite sure. The opposite of well, if we did that one, that wouldn't work, would it? Because that would make it negative. So, in this case, I'm just going to go with negative 32 divided by negative 8 and 32 divided by 8. All right, because it's positive. A negative divided by negative is a positive divided by a positive is a positive, right? I guess we could put a positive like this. It really doesn't seem to make much sense, but I'm not sure what they want for that third one. I'd have to look that up. Interesting. Okay, now what about if we're dealing with decimal numbers? Decimal numbers. All right, so just a reminder, when you have multiplication, right, if I have 7.4 times 3, right, 3 times 4 would be 12, carry the 1, and I would get 2, 2, 2, and then I'd say, okay, well, there's one spot there, and it would be 22.2. So then if I did 22.2 divided by 3, I better get 7.4, right? So when you're multiplying, you count how many digits are behind the decimal in your factors, and then you get that in your product. When you are dividing, what you do is you line up those decimals that way, all right? So, and you can also kind of just think about it logically, all right, what answer you should get here. But if I want to do 2.8 divided by negative 4, first of all, let's look at the signs. Positive divided by negative is going to be a negative. A negative divided by negative is going to be a positive. And this one just has one negative out front, so it's automatically going to be negative. All right, then what do I have to do? I have to do 2.8 divided by 4, right? And I'm going to put the decimal right there because I'm going to line it up. 4 does not go into 2, right? 4 goes into 28 7 times. So I get 0.7, right? And if you wanted to check your answer, if you were to do that answer, if you multiply this times that, you would get that. A negative times a negative would be a positive, and 4 times 0.7 would be 2.8. All right, what about this one right here? What about if we have 0.4 divided by 6.64? Well, now it gets a little more tricky, all right? Because you have to remember back to this trick that we would do, all right? Because we wanted this number here, we want this to be an integer. We don't want it to be rational. So we would move that decimal one place there, right? Do you remember this? And then we'd move that decimal one place there. And what we would get would be 4 into 6, right? 66.4. So we move the decimal once that way. So that gave me, it's 0.4, right? But then we don't need that 0 anymore. 4 into 66.4. All right, and then I'm going to put that decimal right there because in a division problem, you always line the decimal up. Here we go. 4 goes into 6 one time, right? All right, 6 minus 4 is 2. Then I'm going to bring down that 6. All right, 4 goes into 26. 4 times 5 is 20. 4 times 6 is 24, right? And then I'm going to bring 2 and bring that 4 all the way down. And 4 goes into 24 6 times. So I get 16.6. 16.6. All right, last one right here. I have, again, a negative, just one negative, so the answer was negative. So let me do it over here. I'm going to do 5.5. That is my dividend. My divisor is 0.5. All right, again, I have to move that decimal one place over, so I'm going to move that decimal one place over. So when I do this, what do I end up with? I end up with 5 into 55.0, right? Move that decimal right there. Well, great. That's an easy one, right? And we get 11 or 11.0. All right, you could just put 11 if you wanted to. That answer would be correct. If you want your answer to be a decimal number, it would be 11.0. All right. Okay, what about a fraction divided by a fraction? All right, the book talks about a complex fraction. So a complex fraction is a fraction that has a fraction in the numerator and a fraction in the denominator. All right. What we need to remember is that when you divide by a fraction, it's the same as multiplying by the reciprocal, right? Or some people call it keep, change, flip. Or I've heard keep, switch, flip. All right, however you want to think about it. We actually did a review of this earlier when we were very first starting out this unit, because this is the skill we need. All right, so dividing by C over D, that's what we have right here, right? But that's going to be the same when I do that as A over B times D over C. Keep, switch, flip. All right? So when you divide by a fraction, that's what it looks like. Change it from dividing by a fraction to multiplying by its reciprocal. Dividing by a fraction to multiplying by its reciprocal. So you could see right here, that's what they did. They had 7 over 10 divided by negative 1 over 5. They kept it, they switched it, and they flipped it. And when they did that, the answer they got was negative 7 over 2. All right. By the way, right here in this multiplication problem, they did 7 times 5 was 35. They did 10 times 1 was 10. They did a positive times a negative is a negative. And then they divided both of these by 5 to simplify their answer, right? But just a reminder, you can simplify your product or you can simplify your factors. It might have been better here to say, oh, 5 goes into 5 once, 5 goes into 10 2 times, and then we would have skipped down here. 7 times 1 is 7, 2 times 1 is 2, and a positive times a negative is a negative. All right, so don't forget that that is something you can do. All right, so if we take a look at these example problems down here at the bottom, we have negative 5/8, right? This would be negative 5/8 divided by negative 6/7, right? Well, first of all, a negative divided by a negative, that answer is going to be a positive, right? But we're going to change or switch, and then we're going to flip. All right? So I changed from division to multiplication, and I flipped over that fraction to get the reciprocal. All right, and now I'm going to see, can I simplify any of the factors? And the answer is no. So 5 times 7 is 35, and 8 times 6 is 48. And I get 35 over 48. A negative divided by a negative is a positive. We don't usually put the plus there, but it is a positive. This one right here, a negative divided by a positive is going to be a negative. This one right here, a negative divided by a positive is going to be a negative. It's always a great idea to put that sign right at the beginning when you do the problem. That way you won't forget at the end. All right, so this one right here would be negative 5/12 divided by 2/3, right? But dividing by a fraction is the same as a multiplying, keep, switch, flip. All right? This time we can simplify the factors, right? 3 and 12. Well, 3 goes into 3 one time. 3 goes into 12 4 times. And when I do that, what do I end up with? I end up with negative 5 times 1, which is negative 5, right? And 4 times 2, which is 8. So my answer is negative 5/8. And finally, this one right here would be negative 4/5 divided by 1/2, right? But that's the same as negative 4/5. Keep, switch, flip. All right, nothing to simplify on this one, and we get negative 8 over 5. All right, negative 8 over 5. So we did decimals, we did fractions, all right? And now let's go ahead and do some word problems. All right, let's look at number 9. A water pail in your backyard has a small hole in it. Darn, I hate that when buckets have holes in them because the water leaks out. You notice that it has drained 3.5 liters in 4 days. What is the average change? All right, so average change each day. Well, I had 3.5 liters over 4 days, right? I want to know each day, so I want to know how much there was in 1 day. So I need to divide. So I'm going to do 3.5 divided by 4. So remember, when you're dividing a decimal, the decimal goes right there. Does 4 go into 3? No. 0 times. All right. Does 4 go into 35? Let's see here. Well, 4 times 8 is 32. All right. So I can do, 4 times 8 is 32, not 35. Bring that down, 3, and then I bring down a 0. All right, 4 goes into 37 times. 28, right? 2. Bring down another 0. 5. All right, 0.875. So 0.875 what? What do we have going on here? It is liters per day, right? So we had 3.5 liters in 4 days. We divided those liters by the number of days, and we got the average per day. All right, if we did 8.75 times 4, guess what we would get? 3.5. All right, what about number 10? The price of one share of ABC Company decreased by a total of 45.75. So negative 45.75 in 5 days. All right, what was the change of price per day? All right, so this is dollars, right? And this is days. So again, we're going to divide 45.75 divided by 5. And by the way, this is a negative divided by a positive, so we're going to get a negative. Here we go. I'm going to put that decimal right there because we line up the decimals. All right, so 5 goes into 45 9 times, right? Ka-chow, bring down the 0. 5 goes into 7 1 time. Ka-chow, bring down the 5, and we get 9.15. So it went down. The average change in price was a decrease, $9.15 per day, or a decrease of $9.15 per day. All right, what about this one? To avoid a storm, a passenger jet descended. He went down negative 0.44 miles in 0.8 minutes, right? Okay, so what do we want to know? We want to know what it was per minute. So again, we're going to divide. So I'm going to take 0.44 and I'm going to divide it by 0.8. Okay, but here we go. This is one of those cases where we have that decimal out here. So that's going to go over 1. That's going to go over 1. So when we do that, our new division problem is 8 into 4.4, right? Because we drop those zeros. We don't need those zeros anymore. All right, now I'm going to put that decimal there. Does 8 go into 4? No, sirree, Bob. 4, bring down that other 4. Does 8 go into 44? It sure does. Let's see here. 8 times 4 is 32. 8 times 5 is 40. I'm going to subtract those, and I get 4, and then I'm going to bring down a 0, and we get 5. So we get negative 0.55 miles per minute. All right, now if you're going, well, wait a second. They went only 0.44 miles, and now you're saying 0.885 miles per minute. That's because this is less than a minute, right? So we're going in a full minute. We would go further, right? In fact, if you think about it, right, here we go, 44 divided by 8. We could cut both of those in half, right? And then we'd have 22 divided by 4, and then we're going to end up with that 0.55. All right. Okay, I think that's all we're going to be doing in this video. You know what? We didn't do a mixed number problem. All right. Just a reminder, they threw in a mixed number here, but we haven't really been doing mixed number problems. There were no mixed numbers in the multiplication. So just a reminder, how do we divide a mixed number by a mixed number? What we usually do is we change to improper fractions. All right, so we're going to go ahead and change them to improper fractions. Okay, do you remember how to do that? So 5 1/3 is 5 wholes and 1 out of 3. So I take, okay, each of those wholes has 3 parts. So I go 5 times 3, which is 15, plus that one extra. So I get 16 thirds. Okay, so 5 1/3 is equal to 16 thirds. All right, and then what about 1 1/2? Well, again, I have one whole made up of 2 parts each. All right, so 1 times 2 is 2, plus 1 is 3/2. So what we actually have here is an improper fraction like we were talking about. We have 16 thirds divided by 3/2, except that second one is negative, right? So a positive divided by negative is going to be a negative, so our final answer is going to be negative. Remember what we do, we keep, right? We switch, and then we flip. All right, so there we go. All right, and I'm looking to simplify and going, darn, it would have simplified if it were this way, but it doesn't simplify this way. So negative times a positive is a negative. 16 times 2 is 32, and 3 times 3 is 9. So our answer would be negative 32/9. Now, if they wanted that answer back as a mixed number, then we'd say, okay, 9 goes into 32. Well, 9 times 3 is 27, right? So then we get 3 5/9, negative 3 5/9. So this is called an improper fraction. So when you start with mixed numbers, you change them to improper fractions. You do the math, and if they want the answer as a mixed number when you're done, you change it back by dividing and looking at that remainder. Okay, so just again, 32 divided by 9 is 3 remainder 5, right? 9 times 3 is 27. 27 plus 5 is 32. All right. All right. Okay. So that's all I'm going to do for this lesson. But as always, if you have more questions, you are always welcome to ask. Until next time, have a great day, everybody.